On June 6, 2012, a small shadow appeared on the Sun. It was not a big difference, not enough for everyone to notice, but millions of people watched the Sun that day as a small, dark dot moved across it. This small dot was the planet Venus, passing directly between the Earth and the Sun, and blocking a small patch of the Sun's light from reaching Earth. It is a rare event called the Transit of Venus. Venus is the second planet from the Sun, and a very similar size to Earth. The difference in diameter between Venus and Earth is only a few hundred kilometres, which is less than the distance between Brisbane and Sydney. Both planets are very small compared to the Sun. Over 1 million planets the size of Venus could fit inside the Sun. Because Venus is relatively small and more than 40 million kilometres away from Earth, it appeared as a very small dot in front of the Sun and took about 6.5 hours to move across it. In Queensland, people with an interest in science and astronomy were able to watch the whole transit. In Brisbane, people could watch the transit by projecting the light from the Sun and viewing the shadow created by Venus. This allowed safe viewing of the transit without causing damage to the eyes. In other parts of the world, people were only able to see a small part of the transit, or were unable to see it at all as the transit occurred during their night time. People in the east of Australia were able to see the whole transit as it started just after 8 a.m. and finished before 3 p.m. People in Western Australia could only watch the last half of the transit as the sun was just rising. Transits occur in pairs 8 years apart, and then scientists have to wait over 100 years for the next pair to occur. The first person known to observe the transit of Venus was a scientist named Jeremiah Horrocks in 1639. Using a simple telescope, he focused an image of the Sun onto a flat surface so that he could observe the transit without looking directly at the Sun and blinding himself. This is the same method that people can still use today to safely observe the Sun. The next transit was not due to occur for another 122 years, and by this time more scientists were prepared to observe it. Mathematician James Gregory had figured out that the size of planets and the distance between them could be calculated by watching the transit from different parts of the world and making measurements. The famous astronomer Edmond Halley agreed. Although the transit had occurred when Gregory was just a baby, and Halley never had the chance to observe the transit in his lifetime, the scientists agreed that observers should be sent to various locations all over the world when the next transits were due in 1761 and 1769. The measurements that the observers collected could be used to calculate the sizes and distances between planets and the Sun. This could be done by calculating the parallax, the optical illusion that an object moves when you look at it along a different line of sight. Try holding one finger a few centimetres from your nose. Look at it with your left eye closed, then with your right eye closed. It appears to move from side to side because of the parallax illusion. Scientists were sent out to different parts of the world, observing the transit and measuring the time, then collecting their results together to make the calculations. Captain Cook was on a mission to observe the transit of Venus when he came across Australia. If he hadn't been sent to the South Pacific Ocean to view this transit, then Australia's coastline may not have been explored for many more years. New technology has given humans more accurate ways to measure the size of planets and distances between them, but the transit of Venus is still important for scientific research. Scientists used the 2012 transit to find out more about the atmosphere and climate on Venus, and new ways to detect planets in galaxies outside of ours. Scientists will need to carefully plan their experiments and make accurate measurements, as there won't be another transit of Venus until 2117.